Hi, my name is Cassie Lee. I'm a writer, but I'm also an astronomy hobbyist, and I was recently thinking about quantum theory and just had some random thoughts that I wanted to get down. I doubt anyone will ever watch this video, but I just wanted to take it so that I had my thoughts spoken out where I could see them again and where maybe someone else could see them if they understand anything that I'm saying. I'm also like I've just learned stuff that I know from videos and things like that, so I'm not an expert. And if there's anything that you know that debunks any of this or explains it to me, that would be great. Because a lot of this is random. So this is I'm calling it the quantum speed theory right now in my head. Um, but it basically is saying how light is the fastest traveling thing that we know. At least one of them. We have speculations of other things like quantum entanglement and stuff like that, but um, which I'll get to that later. But it's the fastest traveling thing that we know. But what about time? Because though light is, the fastest thing that we've observed, it has to travel in time. And it takes, it only can travel so many miles in a second. So even though that's a ton, it still takes up time to travel. Like, how we're seeing stars that are, trillions of light years away because not trillions, but millions of light years away because it's taking that long for light to get here, supposedly. Um, so light is the fastest thing that we know, but it's not instantaneous. It has to travel through time as well, making time technically faster. Now, I've looked this up, and a lot of astronomers and astrophysicists say that no, time is not faster because it can slow down based on Einstein's theory of relativity. It slows down around more massive objects, at least to the observer. Time does that, but also light does that too because it has to. To the observer, it warps around that space-time and the gravity, and it has to slow down if time is also slowing down. Otherwise, that wouldn't make sense. So, I'm kind of thinking that time. You can't say that light travels faster than time because that doesn't make sense. You can't travel through time faster than time. So anyway, yeah. So according to Einstein's theory of relativity, time is not a human-made construct like a lot of philosophers say. That they'll say time is fake, time is irrelevant, but it is a finite thing that can change, and according to time dilation, whenever it gets around a more massive object, time will slow. So if you've seen the movie Interstellar, they go to that one planet, I don't remember what it's called, but they're on the planet for maybe like 30 minutes, and then they go back to their ship, and their astronaut friend has been waiting for them for like 7 years because he's been up in space observing while they're down here around this massive object that makes time slow down a lot. So yeah. This means that a black hole is obviously the most massive object that we know of. So in time, black holes eat matter, they eat light, as you know, but they also eat space-time. So according to Einstein's theory of relativity, in a vacuum of space, space and time meld together to create space-time, and they are one. They morph together, so when space and gravity bend around a more massive object, that's why time also does that. So in a black hole, it eats everything, including space-time. So time basically stops at a black hole at the event horizon, which is the point in where nothing comes in and nothing comes out. or nothing leaves. Everything comes in. Nothing comes out. So if you've seen like a black hole diagram, it's basically like this little funnel shape. And right here is the event horizon where anything that comes in is done. Then right here is a point called singularity. And then some diagrams will also show another identical mirror funnel coming out this way that is called a white hole, but we'll get to that in a second. Basically the question is, if time can slow and has a point when it stops at a black hole, then should there be a point where it can also speed up? Because if we're saying that time is not the fastest thing, then there should be a point that's faster than it. So, yeah. So this is all to say what would happen if you went faster than the speed of time. Now that doesn't really make sense because speed is the amount of distance that you can go over a certain period of time. So, light's the fastest thing because it can go the furthest in the shortest amount of time. But, so you can't really say that time has a speed because that's instantaneous, and you can't go faster than that because you need time, which is part of the equation for speed, to create speed. So it doesn't really make sense. But just bear with me. We've speculated, as I said, that there could be white holes on the opposite end of the singularity of a black hole, which would mean it's the opposite of a black hole where nothing can enter at the event horizon instead of nothing being able to leave like at a black hole. So this basically makes the white hole so bright, so white as it's called, because unlike a black hole, it wouldn't be sucking in light, it would be reflecting that light back and shooting it right back, and not just reflecting it like, like a mirror or something. It would literally be taking the essence of the light and shooting it back. So the question is, if a black hole sucks in light, a white hole shoots back light, then what does it do to space-time? Because a black hole sucks into space-time, so that would mean that a white hole reflects back the space-time. And this means that basically space, which is a whole nother thing, and time would kind of be layered on top of each other because, if you have lights coming in and you have more light bouncing back, that's light hitting each other, which just makes it brighter. But if you have space and time coming and hitting each other, that creates like two different layers of space-time that are like stacked on top of each other, which isn't really possible, but would also bring you to this speed that could go faster than time normally. This is just like how I'm visualizing it in my head. So it's probably not how it would work, but I'm just saying if time stops at a black hole, then what if it sped up at a white hole? Because they're complete opposites in like everything that they do in all of their functions. So anyway, so since speed couldn't exist without time, the ability to exceed time speed would mean that you'd be in a lot of places at once, or at least in two places at once, because you'd be, like say I'm a person watching you, you are exceeding speed of time. So you're here, you're at point A 1 second, and then now you're suddenly at point B 2, both times, because you're moving faster than the time that I'm observing. So you're right here, basically in the future, while I'm still back here, and you're in both places at once. That's how I'm seeing you. But there's also a thing where it might be that you were duplicated like a million times over that space, however many, like every single millimeter of space that you covered, you'd be multiplied that many times around, and that's how I would see you. Which is interesting because it's been theorized, I don't know, at the event horizon of a black hole. If you went in, I saw an animation about this. If you went in and reached there, you'd basically see a ring like mirrored a bunch of different versions of yourself around the ring of the event horizon right before spaghettification, where you're literally just destroyed. But this kind of, illustrates like the image that I'm thinking of, that you would have to be in multiple places at once to be traveling faster than the speed of time, because you're in two places at once because you're going faster than that, at least for us as an observer, which is also interesting because Einstein's theory of relativity technically doesn't say that time dilation is like finite, like that time itself slows around that object, but it just slows compared to an observer. So that's what I'm thinking. And that brings me to the part of the theory of relativity that states that time is the fourth dimension, and this is the most important part. So this is going to take a little bit to explain, but basically the most important part of this time speed theory is that you're thinking of what a normal person in a normal time like me right now is observing. So to explain the different dimensions to you, I've been studying them since I was younger because I wrote a book about them in like 7th or 8th grade. But first, it's most important to note that there are only beings on the third dimension, because that just doesn't really make sense for them to exist in other dimensions that we know of. So there's the first dimension, which is just 1 point. So you're basically stuck at 1 point. That's all you know. That's all there is. That's all you can see. The second dimension is basically a line. So that line can go any way, but it can only go, left, right, up, down, directions like that. It can't go forward or back like we can. So it only has height and width. Yeah. Whatever. Height and width. And then the third dimension, which is what we are, what all beings are as far as we know, hopefully, is height, width, and then depth. So we can go up, down, left, right, forward, backwards, whatever. And this is interesting because if there was a being in the second dimension, number one, we know there's not, because we would be able to observe them in a way that they can observe us, because they're on a plane that we can see and we're a higher plane than them. So basically, if one of us stepped into this plane, it would just be weird because they, would only see up, down, left, right. They would have no dimension, so it would just be like this weird blob shape passing through there. Like, it just wouldn't make sense. It would just be one little slice of us and what we are stepping through. So it'd be like, if I step on a piece of paper, all of that, the second dimension being on that piece of paper would see was like the tiniest little slice of my foot, and they'd be really confused. So basically, us as a third dimension, if there was a fourth dimension, especially with beings, we would not be able to understand them. We wouldn't be able to see them, and then if we somehow did, we wouldn't be able to understand what we were seeing, or be able to detect it and fully see it. It would just be weird to us. They would probably appear kind of like weird balloons to us, with everything just floating around, because we wouldn't be able to understand what we were looking at, and all their pieces would be layered on top of each other in a weird way that we wouldn't understand. And they would basically, like, imagine I take a piece of paper, that's the second dimension. I draw a triangle, I draw a little squiggle in that triangle. The only way for the squiggle to get outside of the triangle is if by itself, as a second dimensional being, it wouldn't be able to get out. It would have to go through the triangle, like how I would draw it. I would just draw a line through. It would have to go through that, but it obviously wouldn't be able to because that's like a solid line. So it'd be trapped and have no way out because it doesn't know that it can go up because it's not part of the third dimension. But me, as a third dimensional being, I could go into the triangle and erase that squiggle, draw it on the outside, or I could, erase part of the triangle, like I can affect it, or I could even cut out the squiggle and move it up and out of the triangle if I wanted to. This just shows that if there was a fourth dimensional being that we didn't know about, it'd basically be able to like maybe reach into our stomach and take out our breakfast without affecting us. We wouldn't feel it. We'd just be able to go through that matter because it's at a different point that we can't see. That was a little bit of a digression. I'm obsessed with dimensions and stuff, but this is to show that if there was a speed that could be reached that's faster than time, we wouldn't be able to see it if Einstein's theory of relativity is right, that time is the fourth dimension, because we can only see forward in time, but we can't see backwards directly, but we have pictures and things, but we can't directly see backwards in time. We can't see forward. We can see like what's going forward right now, but we can't see the future in time, or any other level of that. We can't see alternate times or anything, but there could be this, time might not just be this infinite line that's going forward. It could be something fluid that goes forward and backwards and all around, and we just as third dimensional beings can't see that, and there's a fourth dimension where that exists. Where was I going with this? Oh yeah, so like I said, it would be like if we as third dimensional beings stepped into a second dimension, they just wouldn't understand what they were seeing. But they could still be seeing something. They could still observe this strange thing, they just can't fully see it. If time was another dimension, we would never be able to fully see or understand this fluidity of time. We would not be able to control that or do anything with that probably, but we could observe it. So think of like how we theorized Planet 9 by basically observing how objects and asteroids and stuff move around it. We noticed that a lot of them had an abnormal orbit for being uninfluenced by anything else. So we theorized that there's a Planet 9 there, or could even be like a grapefruit-sized black hole is what some scientists think might be in Planet 9 space. I also heard they just think they might have discovered a Planet Y, which was very interesting. But anyway, or you can think of how we use the transit method to discover exoplanets. Like, we don't look at the exoplanet directly, we observe its effect on the dip in sunlight. Or how we discovered black holes in the first place. You can't see black holes because they're completely dark, but we observe how they absorb light around them. So while we can't directly see some of these things, or like dark matter, antimatter, whatever, things like that, we might not be able to directly observe this fourth dimension of time and a speed further than time, but we could observe it and see its effects around us. So I'll get to that in a second. And in the same way, it's like how we can't see some layers or levels of the universe, like dark matter, like I said, or certain light, like ultraviolet light. I'm talking too much. Or red light, or something like that. We can't see it, but we do have technology that we've invented that can see it. So maybe eventually in the future there would be some sort of technology that could detect this fourth dimension of time and this speed ahead of space-time. And yeah, but who knows. So, as I was saying, we could maybe indirectly observe this fourth dimension of a speed faster than time. And one of the ways that I think we could do it actually already exists and has been proven, which is quantum entanglement. If you have heard of that, it's really interesting. It's like these two particles, I think they usually say that it happened at the beginning of the universe, that these two particles, well, sometimes, actually a lot of the time, I think with quantum entanglement, these two particles have never met, but some invisible force that we can't see has tied them together, entangled them together, where they are basically exact copies of each other. Everything one of them does, the other one does simultaneously. So if my finger moves like this one's gonna start doing it at the same time, even if they've never met, they've never connected in any way. There's no explanation of what this entanglement is between them that's making them both react at the same exact instantaneous time, despite that they're across millions, trillions, billions, trillions is more than billions, miles of space and time apart, where anything else, like light, it would take even light a really long time to reach both of those particles. They're reacting at the exact same time, which means that they're doing something, they have some sort of connection that travels instantaneously beyond the speed of time or at the exact speed of time. So that's really interesting because, I mean, yeah, we can't figure out what happened and that, how that works, and that kind of connects to my theory because time is moving so fast that these two things are reacting at the exact same time, and that means that there has to be some speed that is something that is moving that at the speed of time or over the speed of time, making these two things in the exact same place at once, moving together at the exact same time when they're like so far apart we can't even imagine it, which is what I was saying about how if you were to go faster than the speed of time, you'd be in two places at once to the observer, and this would make it essentially teleportation will also be a form of time travel, which could mean that we could also go back in time using this, but who knows. And then the final thought I had about this was that it could also connect to the string theory and the quilted multiverse theory. So the string theory, you've probably heard of it. It's basically that there are these vibrating strings that are like the smallest thing, smaller than atoms, like the smallest thing in the universe, and everything is made up of these vibrating strings. But some strings are vibrating at a different frequency, which could be a different speed of time, could be faster than time or slower than time. Well, slower than time we've already observed, obviously, but it could be like faster than time. And that basically makes a layer of reality on top of ours that could make different dimensions that are layered right on top of us. There's a whole nother dimension going on around us. We just can't see it because it's vibrating at a different frequency than us. And then the quilted multiverse theory is basically that it's essentially that not the universe, but space is infinite and it goes on forever, but there's only a finite amount of arrangements that particles can go into. So if you have like, I don't know, say like a deck of cards only has a certain amount of arrangements that it can be put into, whatever. I've heard different analogies for that, but well, space is infinite, the amount of arrangements within it is infinite. So that means that eventually everything has to repeat so many times that there's an exact copy of this Earth with these conditions, with this person, with this you, with this, everything is exactly the same in this universe as in our universe. That's how many universes there are, that there has to be an exact copy of this one. Infinite amount of times, basically. But states that it would be like 10 to the 10th to the 118th power light years away, there would be another universe the exact same as ours with another us on it. And this is just interesting to me because it could be another thing like this quantum entanglement or this speed faster than time, or these two things are interacting the exact same and they're connected somehow, reacting the exact same at the same time, same copies of each other, even though they're not connected. And this could just be, again, because the quantum multiverse theory says that there's only a certain amount of arrangements that things can do, but I feel like, I don't know, that's just hard to grasp. As a human who doesn't understand an infinite amount of space. But I just think that really time is something that we ignore a lot more, and I really admire that Einstein was looking into it a lot and made his theory of relativity and thinks that time could be the fourth dimension, because I definitely agree with that with him. I mean, when I was little, what I thought was that teleportation was possible eventually with science, but time travel was not at all even kind of possible, because teleportation, you can move everything through space really fast to another area really fast, faster than humans could walk or fly or drive somewhere. But time travel, you can't go back to something that's already happened, or you can't go forward to something that hasn't happened yet. But with Einstein's theory of relativity and with this theory of time speed, maybe time travel and teleportation could go hand in hand, and time travel could be not as, ridiculous and science fiction as teleportation. So those are just my thoughts. This went on way too long, but I knew I was going to be talking about it forever. But this was just some of my ideas about my favorite parts of quantum theory and Einstein's theory of relativity, and it combined all of my favorite theories, like the quantum multiverse theory and time is the fourth dimension and stuff. But so yeah, those are just some thoughts. If you have like any corrections on anything I said, or how that wouldn't make sense, or if anything I said made sense at all, you can comment about it. But yeah, thanks. If you somehow listened to all this, you're probably asleep by now, so sleep good. Good dreams about quantum theory. Bye.